Before we get into Chapter 9 notes, I want to review on tables and graphing. When we make a table, we have our T table. On the left-hand side goes X, on the right-hand side goes Y. You pick your points for X. I always pick -1, 0, 1, and 2. Because the arithmetic with these numbers, arithmetic meaning the math, are easier than if I would pick 77, 78, 79. You should pick at least 4 numbers for your X values. My first number for X is -1. So I take my equation, y equals 2, and I write -1 in the X spot. So I get -2 minus 3, which would give me -5. If I put 0 in for X, 2 times 0 cancels out, and I'll just have -3. When I put 1 in for X, I get 2 minus 3, which would give me a -1. And when I put 2 in for X, I get 4 minus 3, which would give me 1. When I'm graphing and I already have my t-table made, you can do this one of 2 ways. You can plot your points, -1, -5. Zero, -3, negative or +1, -1, 2, 1. And then extend your line and make sure to write arrows at the end. The other way that you could do this is a linear function. That means y equals mx plus b. B is where it crosses the y-axis, and m is my slope. So if my b is -3, that means I would go down 3 and plot that point. And my slope is a +2 over a +1. So that means up 2 over 1. And I could just plot those 2 points, draw my line, and extend and draw arrows. Either way, you'll get the same answer. On to Chapter 9, Lesson 1 notes. Multiple representations for functions. While I'm going through the notes, if you have any questions, please write them on your notes so that you can ask me in class. Also, I'm going to be going through the lesson without any stops. So if we're working out a problem, push pause so that you can work out the problem and compare it to the answer that I have. First, I have 3 different graphs. I'm going to be labeling them A, B, C. I have to match these graphs with the different sentences that I have given. The first one is, the park was closed on Friday for repairs. Without even looking at the graphs, if the park was closed Friday, that means they didn't have any sales on Friday. Looking at the 3 graphs, I know that the only possible choice is C. Second question, the park hosted a big concert on Saturday and a parade on Monday. To me, that says that the park made a lot of money on Saturday and Monday. With the 2 remaining graphs that I have, both Saturday and Monday are high, so I'm not sure which one it is yet. But if I read the next statement, the park was very busy during the holiday weekend. That means that the park made a large amount of money all 4 days. So that only possible answer there would be B. So that leaves A is the graph for the concert and parade. Now I want to sketch a graph given this information. Ticket sales were good until a massive power outage happened on Saturday evening that was not repaired until late Sunday. So Friday ticket sales were good. Good sales to me would be around $8,000. Massive power outage happened on Saturday evening. So that means that there could have been a lot of sales in the morning and afternoon, but then didn't get any sales at night. So I'm going to say that it went down to 4,000. And it was not repaired until late Sunday. So mostly, if you're going to go to the music park, you're going to spend your whole day there. So I'm going to say maybe they got 3,000. And then on Mondays, you typically don't get as many sales as Fridays. So I'm going to say they got maybe 6,000. And connect your dots. Your graph might look a little different than mine, but as long as you have that Saturday, Sunday were lower than Friday and Monday, you have the right answer. Janet is rowing across a 80-meter wide river at a rate of 3 meters per second. Whenever you see rate, that is always your slope. So my m will be 3. When I'm labeling making a table, I have my x and I have my y. My x will be my seconds, and my y will be my meters. If for some reason you're not sure of why I have seconds and meters, my slope is meters per second. When I ever find the slope, it's always the difference of y over the difference of x. So my y is on top here, which is m, and my s is on bottom, which is x. So if I'm making a table, at 0 seconds, she is 80 meters away from the shoreline, because the river is 80 meters wide. At 1 second, she's growing 3 meters per second. So I actually have to take away 3 meters. She's running across. So this would be 77. So my slope, 3 go over, is negative 3 meters per second. After 2 seconds, I have to take away another 3 meters. So I'm at 74. At 3 seconds, should be at 71. At 4 seconds, should be at 68. So I have to graph this. I'm going to have my x goes in tens, or my x go by ones, and my y go by tens. So my first point I have is 0, 80. Now, because my squares are so small, the next point that I'm going to plot is 371. The reason why is because 71 is close to a 10 increments. So I'm going to go over 3 and up 7. So it's about right there. And I'm going to draw my line. Make sure to extend and draw the arrows. Last thing I have to do is draw an equation. If I'm finding my slope, well, the slope is actually already given to me. So I still go with the equation y equals mx plus b. I know that my m is negative 3. B is always where it crosses the y-axis. By the table, I already know that when x is 0, y is 80. So I know that my B has to be 80, because when x is 0, y is 80. And the question is, when will Janet reach the shore? The shore length is going to be my y. So it's asking, when is y going to be 0? So if I put 0 in for y, I have to solve for x. X is my time. I have to subtract 80 from both sides. and then divide by my negative 3. Negative divided by negative will give me a positive answer. If you did this in the calculator, you would get 26.6 repeating. If I want to shorten up and not have a decimal, 6.6 repeating is going to be 26 and 2/3 seconds. Make sure that you have your units. My next question, Stacy runs 3 days a week at a track. Stacy starts keeping time when she starts warming up and notes after every 2 laps how long has been at the track. The table shows the times for several laps. We have to graph and write an equation to find the time it will take Stacy to run 20 laps. Typically, time is going to be your x, but when they give you a table like this, my x is going to be my laps, and my time is going to be my y. So when I'm graphing these points, make this a little smaller. I'm going to label my graph also, so I have laps on the bottom and time on the side. My first point is 2 laps in 13 minutes. So I'm going to go over 2 and up 3, or 13. 1, 2. And then I have 4 and 16. Six and 19. And all I really need are 2 points. And I'm not going to get all of my numbers, my 822 and my 1025 on the graph. But I can still draw my graph as is. So when I find my slope, slope is always my difference of y over my difference of x. So this would be 16 minus 13 over 4 minus 2, which will be equal to 3/2. To write my equation, I'm going to use point-slope form. Point-slope form is y minus y1 will be equal to my slope x minus x1. When I'm finding my equation, I can use any of the points that are given on my table. I'm going to use 2 and 13. So I put 13 in for y1. I know my slope is 3/2. And I put 2 in for x1. I first distribute my 3/2 in. So I have y minus 13 is equal to 3/2 x. 3/2 times a negative 2 will give me a negative 3. I have to add 13 to both sides, and y will be equal to 3/2 x plus 10. Now looking at my graph, I could have assumed that when x was 0, y was 10. But you should always figure it out mathematically, because this isn't exactly, my line wasn't exactly straight, and it wasn't exactly at 10 right here. So you should always use the point slope form to find out exactly what your equation is. And my question is, how long will it take Stacy to run 20 laps? Laps is my x. So if I put 20 in for x, I'll have y equals 3/2 times 20 plus 10. 20 is the same thing as 20 over 1. I can reduce my corners because they're multiplying. 3 times 10 will give me 30. Plus 10 would give me 40 seconds. The table shows the height in feet of an arrow in relation to its horizontal distance from an archer. Create a graph, an equation, and a verbal description to represent the height of the arrow with relation to its horizontal distance from the archer. We're not going to write an equation, but we are going to graph and write a verbal description. So using this graph, my x is my distance from the archer. And my y is going to be my height. I'm going to have my x's go up by 50. And I'm going to have my y's go up by 10. So this would be 100. So distance from archer is 0, and the height is 6.5. At 75 feet away, it's about 60 feet in height. So I had to make sure to put my dot in between for the x's because each box is worth 50. At 150 feet away, it's up to 90. At 225, it's about 98 or close to 100. At 300, it's close to 85. And at 375, it's close to 50. A little less. So if I connect my dots here, and if I keep on going down, roughly, that's not that great of a... And I also have to write a verbal description. So since this is a parabola, it looks like my height reaches roughly about 100 feet away at roughly 225 feet horizontally. So I could say the archer shoots the arrow at a height of 6.55 feet. It travels horizontally to its peak, the highest distance that the arrow is at, about 225 feet. With the height roughly 99 feet. And that would be my verbal description. Make sure to write down your homework, or else you can look at the calendar that I have online too to find out the homework for 9-1. On page 658, 1 through 13, and 38. Have a great day.